Okay, so what we're going to look at now is what we call passing an island or distance off an island. Okay, now what that actually is in reality is just finding a latitude for a given longitude or finding a longitude for a given latitude. Okay, that's all we're going to do here. Now, the way the question will say it will say something like, calculate the distance north or south that the vessel passes the island when it's on the Great Circle route. Or calculate the distance east or west that the vessel passes an island. And it will give the position of an island or a volcano or an underwater obstruction or something like that. So in this case, we'll do, I don't know, so we're going to use the question that we used on the previous examples, with the distance, the initial course that we're working on over there, and then this vertex here. So the question will say something along the lines of calculate the distance north or south of the island in position 45, 30 minutes north, 37 west. What we have to do is first find out what type of question this is. There are only two. We're either finding a latitude for a given longitude or finding a longitude for a given latitude. Okay. Originally, this concept was just finding a waypoint on a great circle. Okay. But what they've done with the advent of ECDIS and people not doing that anymore, they thought a much more practical way of asking this would be calculate the distance off an island, because you do that all the time. So we need to find out which component here we know. Okay. The way to think about it, there's your island. Okay. If you're north or south of it, you must be on the same meridian as it. Okay. So if you're on the same meridian as it, you must already know that longitude. So if you want to find north or south, you know that longitude. So you are trying to find a latitude for a given longitude. And if you think that makes sense, find the latitude on here. There's the island. What latitude were you? There's your distance. Happy days. So if it's north or south, you know the longitude. You need to find px. Okay, you'll see what I mean by that in a second. If I said to you, calculate the distance, we'll do it in a different colour just to differentiate it. If I said to you, calculate the distance east or west of the island in that position, now, if you're east or west of it, you're somewhere on that meridian. So if you think if you're there or there, you know the latitude. Okay, so it's east or west, you know the lat. So you know what the colat is, so now you need to find D long. You need to find P3. Now what I'll do is get rid of that and explain what Px and P3 are. On Great Circle, we went from A up to the vertex and then down to B. And then we said, right, the vertex was somewhere not far away from the initial position. So that was your 4950 north, 515 west. That's your 3229 north, 64 west position. And the vertex, as we discovered, was at 49 degrees, 50.4 north, and 6 degrees, 29.8 west. And we want to know how far north or south we pass of that island. Well, north or south, as we said, means we know the longitude. If you think about it, I can put a little, I'll do a different colour so it's not going to get mixed up. There's position X. There's 37 degrees west. There's an island somewhere near here. Okay? North or south, I know the longitude. So I know that that meridian is 37 degrees west. Has to be because it's the meridian of the island, and I want north or south. I know this meridian is 006 degrees, 29.8 minutes. And I know this latitude was 49 degrees, 50.4. I don't know this latitude, I only know the latitude of the island. Well, the island isn't going to be on my great circle, otherwise it would be calculate how hard you hit the island on your route. So what I do is I draw Napier's wheel out again. This time, I'm only going to focus on this internal triangle. Okay, I'm going to get rid of these bits around it. What I have, there's P3 at the top, the D long. We'll just call it P3 to differentiate it from P1 and P2 that we've got there. Got a vertex. I've got an angle X as I cross the island. And what I have is a PV, P3, a PX, a little x, and an XV. Obviously that's the complement again. I know PV because I know the latitude of the island. Regardless if this is a north or south or an east or west question, you will know PV. Okay. And because I've been told I want to go north or south, if I've got to go north or south, I have to be on the same meridian as it. If I'm on the same meridian as the island, and the meridian of the island was 37 west, so I must be more north or more south from this position, so I need to find what that PX was. So I need to find PX, and therefore, P3, if I know that longitude and I know that longitude, I can work it out. I can work out what P3 is. So I can say, okay, PV equals, straight off there, 40 degrees, 09.6 minutes. P3 is going to be the difference between 37 west and 629.8 west. So that's going to be 30 degrees, 30.2 minutes, and it was west. Oh. If I know P3 and I know PV, I now know two components of the wheel. Remember the vertex is there, but it's not a mid part. So now, what I can do is do the formula. I can't make PX a mid part because I don't have two adjacents, I don't have two opposites, but I can make P3 the mid part and have PV and PX as the adjacents. So sine the mid equals tan of the adjacent times the tan of the adjacent. And then sine of the complement of P3 equals tan PV times 1 over tan, sorry, the tan of the complement of PX, 1 over tan PX. Right then full first. So cos P3 equals tan PV times 1 over tan PX. Cos P3 equals tan PV divided by tan PX. All we've done is change PA or PX. It's the same formula, we're just trying to find the midpoint. We've already done it there for the longitude. So, now though, I want PX. Well, I just transpose that formula. Tan PX equals tan PV divided by, got off tangent a bit there, cos P3. So, if I plug the numbers in, move that down a bit. When we put the numbers into that equation, we simply do tan of 40 degrees 9.6 minutes divided by cos 30 degrees 30.2 minutes equals, that's right, okay. So px equals 0.979421881. Oh, sorry, there's a ton of px. So px is 44 degrees 24.3 minutes. Now px is the difference from the pole to the latitude of x. PV was the pole to the vertex. If we knew the latitude of it, we could find PV. PA is 90 minus PA. If you wanted to get A from PA, you would do 90 minus it again. If you want to get B from PB, you would do 90 minus PB again. Goes both ways. So we know PX, so to get the latitude of x, it's just going to be 90 degrees minus PX, which is going to be 45 degrees, 45 degrees, 35.7 minutes north. So now we know we crossed the meridian of 37 west to 45, 35.7 north. Well, what was the island? The island was 45.30 north. Therefore, we're passing at 35.7 north, hits at 30.30 north, therefore we pass 5.7 miles to the north of the island. And that's how you do passing an island, for north or south. East or west, slightly different. Okay. So what we do, get rid of that. Change the position of it. Until we have a different cloth. What we're going to do now is look at east or west of an island. Okay. East or west of an island is very similar, but we have a very slightly different step at the end, which people often overlook and trip themselves up with. So, say calculate the distance east or west of the island in position, let's say 40 degrees north, we'll keep it nice and simple. I don't know, 51 east. Sorry, west. Great, so I didn't go for east, but it was 5:15 there. So, calculate the distance east or west of the island. This time, if you think of our great circle diagram again, we've got A to B, there was the vertex, there's point X. Again, we're going to get rid of these components around it and just have the V to X triangle, same as last time. And we're going to draw an Napier's wheel out. So right, what we've got, same as last time. I'll call that P4 just to differentiate it from the previous question. This is now a totally different island, totally different position. Got PV, P4, PX, little x, XV, vertex at the top, get rid of it for the mid part. There's your complement. Now what we do is you say, right, if I'm east or west of the island, if you just think there's the island, east or west of it, I must be on the same parallel of latitude. If I'm on the same parallel of latitude, like last time, as I said, you always know PV in these questions because you need a vertex to have that point to be able to work out the 90 degrees triangle for all these bits. If I'm on the same parallel of latitude, I must know the latitude. So I must know PX. This time, I need to find P4. So for east and west of the island, I need to find P4. Well, this one's nice and easy. Sine of the mid part, tan of the adjacent, tan of the adjacent. There you go. It's the same formula as this one, which we said was the same as the one we used on the last one. This time it's the same formula, there's just no transposition. So it's tan of the adjacent times tan of the adjacent, sine comp P3, or sorry, P4 in this case, equals tan PV times tan comp Px, cos P4 equals tan PV times 1 divided by tan Px. So cos P4 equals tan PV divided by tan Px. PV, as we said, was 40 degrees, 09.6 minutes. Px is going to be 90 minus the latitude. So the latitude is 40. So Px is going to be 90 degrees minus 40, which is going to be 50 degrees. So it's going to be tan 40 degrees, 9.6 minutes divided by tan 50 degrees. And that'll tell us straight away angle P. So tan 40 degrees, 9.6 minutes divided by tan 50 degrees equals cos. So cos P4 equals 0.7080906.3. So P4 equals 44 degrees, 55.2 minutes. It's west of it. That angle, by the way, would be the same to the east side of it to cross 40 north, but obviously we want to know how far east or west of the island we were. So we use the position of the island because that's the side it was on. The one over this side, if you like, we're not anywhere near the island. This one's obviously much closer to the island that we passed. We didn't pass the island over this way, so we can't say the distance east or west of it because we didn't go there. So the longitude of the vertex was 629.8 west, 006 degrees, 29.8 minutes west, which means the longitude we crossed at point X is going to be that plus that, which is going to be 0.50051 degrees, 25.0 minutes. So the island was at 51. So we were 25 minutes west of the island. Notice I said minutes. Calculate the distance, not calculate the d long. What we have there is a d long. That's not a distance, it's d long. So what we have to do now is say, right, okay, I want distance. Well, how can I find distance? Well, we're on the same parallel of latitude. If you think what we said in the plain sailing section, departure is the east-west distance between two meridians. Well, I'm on the same parallel of latitude, so I do just need the east-west distance between those two meridians. So departure equals d long times cos mean lat. Well, I know my d long, that was 25 minutes. Remember, we keep d long in minutes when we work, because we're doing a plain sailing bit now. The mean lat is just going to be the same latitude. We haven't changed latitudes. The island was on 40 north, we're on 40 north, we just want to know how far east or west of the island we are. So, departure equals d long times cos mean lat. which equals 25 times the cosine of 40 degrees, because that's the latitude we're on, tells us we pass 19.2 miles, because we just go to one decimal place. So the distance equals 19.2 miles. Point X, where we were, was 51.25 west. The island was at 51 west. So it's less west than us. Less west is more east. So we pass 19.2 miles west of the island. And that's all it is. Passing an island is just finding a latitude for a given longitude, or finding a longitude for a given latitude. If you're told to go east or west of the island, that must mean you're on the same parallel of latitude. If you're on the same parallel of latitude, you've essentially been given the latitude. So what you're trying to do is find a longitude for a given latitude. East-west longitude, you're trying to find the longitude. North-south off the island, what you've been given there this time is if you're north-south, you must be on the same meridian as it. If you're on the same meridian as it, then you must have the longitude. So essentially, you've been given the longitude. So for that, what you're trying to do is calculate a latitude for a given longitude. And that's all it is. Okay? We're trying to find either a latitude for a given longitude or a longitude for a given latitude. Essentially, finding a waypoint. That's all we're doing. Originally, this would have been used, like I say, on great circles. You would have said, right, okay, calculate the longitude that I crossed 20 degrees north. Or calculate, more likely, you'd have picked every meridian going across the ocean, 50, 60, 70, 80, and so on. Said, right, what latitude do I cross each meridian so I can plot them on the chart, join them as a series of run lines to actually do a proper great circle. But, as I say, SQA and the colleges and the MCA have changed the concept of a bit, and now we look for a latitude for a given longitude.